Calc students. I'm Tyler, and I am measuring how much coffee is dripping down into a cup from 0 to 6 minutes. And I came up with this awesome table here. This is the minutes, and this is the ounces. Okay, the first part of the question here is asking us to use the data in my table here to approximate C prime of 3.5, which is asking us for the slope of C of t, which is this, at 3.5, which is like y over x, or the rate of change. To find slope, we're going to take y sub 1, y sub 2, minus y sub 1 over x sub 2 minus x sub 1. Next, we're going to plug in the values from the table at 3 and 4, because 3.5 is in between those, to find the slope there. So we got our y's on top, so that's 12.8 ounces minus 11.2 ounces over 4 minus 3 minutes. And now we have to do this very difficult math in our head, since this is a no calculator problem. And we're going to get 12.8 minus 11.2 is 1.6, and that is over 1. So 1.6 ounces per minute. Boom. Alright, it's time for the second question. Second question is there a time t from 2 to 4 where C prime of t is 2? So that's asking, is there a point on C where the slope is 2? Alright, the easiest way that we're going to be able to do this is just by using the mean value theorem. This is a very important theorem, and you're definitely going to need it for the AP test. Probably. So just learn it. Okay, so the mean intermediate value theorem says that if you have some function f of x and it's continuous on some interval a to b, continuous and differentiable, that there will be some point c on that interval from a to b, that f prime of c equals f of b minus f of a all over b minus a. Alright, to better help you understand the mean value theorem, I drew this graph here with a, b, and their corresponding y values, f of a and f of b. And what it pretty much is saying is that the slope between the points a and b equals some number as long as it's differentiable and continuous, and that there has to be some point c on this interval that the slope of that point is equal to the slope of this. So if we're looking at this, you're probably going to find a point about right here where the slope is about the same, but that's pretty much what the mean value theorem is. So again, our problem's asking us if on the interval from 2 to 4, is there some point where the slope is 2? Well, since we are told that this function c of t is differentiable and therefore is continuous, then we can use this mean value theorem right here. So we're going to plug in the values for 4 and 2 into this. So it's going to be f of 4, which is 12.8, minus f of 2, which is 8.8, over 4 minus 2. And then again, this is no calculator, so just do it in your head. 12.8 minus 8.8, which is 4, over 4 minus 2, which is 2. So we get 2. So that's pretty much saying that there has to be some point C on the interval from 2 to 4 that the slope of that point is 2. So therefore, yes, there is a point. Okay. Next, we're going to have to use a midpoint sum with 3 subintervals of equal length to approximate 1/6 times the integral from 0 to 6 of ct. And then the second part of the problem is to explain what that means in relation to all of this stuff. So if it's not clear how exactly to use the midpoint sum theorem with 3 subintervals, I drew this graph out so you can see it clearer. So we're going to have 3 subintervals, so we're going to break this up between this one, and this one. And then we just find the midpoint of these two. So that would be, or the value is at 1. And then this one would be the value at 3. And this one would be the value at 5. That's a little bit off. But then all we need to do then is find the value of these rectangles here, and then divide by 6 to get our answer. Alright, so now we're going to find our areas of our rectangles and divide it by 6. So first one, we got 2 times 5.3. And we're doing this in our head, remember, so it's going to be 10.6 for the area of our first rectangle. Second rectangle, we got 2 times, what is 3? 2 times 11.2, which is going to be 22.4. And then we got 2 times, what is 5? 13.8, which is 27.6. And now we just got to add these all up, and then we're going to divide by 6. So we got these values, and we're just going to add them up. So 10.6 plus 22.4 plus 27.6 all over 6 is going to equal, let's see, 60.6 over 6. And then you can just do that long division if you need to, or if you can just think about it, it's going to be 10.1. So then now what we got to do is we got to think about this in the context of our problem. So our answer is 10.1, but what are the units going to be, and what does that actually mean? Since we are adding up the number of ounces in the cup and dividing by 6, which is the minutes, we're going to get the average number of ounces in the cup over the interval from 0 to 6. So that's what 10 is. 10.1 is the average number of ounces in the cup from 0 to 6. Alright, the final question is asking us to find the rate at which the amount of coffee in the cup is changing when t equals 5. And they're giving us that the amount of coffee in the cup at time t is this. So what we're going to do now is we must find the derivative of this, because that is telling us the rate at which the amount of coffee in the cup is changing. So again, we have b of t up here, which is 16 minus 16 e to the negative 0.4t. And then we are going to be taking the derivative of this. So b prime of t is going to equal, the derivative of 16 is 0. So 0 minus, and then it's going to be 16 e to the negative 0.4t times negative 0.4, since we have to use the chain rule. So it's going to be negative 0.4 times 16 e to the negative 0.4t. And then we're going to simplify this some more. We're going to get 0.4 times 16 e to the negative 0.4t, which equals 6.4 e to the negative 0.4t. And then now all we have to do is plug in 5 for t. So b prime of 5 is going to equal 6.4 e to the negative 0.4 times 5. And that's going to be 6.4 e to the negative second, which is the same thing as 6.4 over e to the second. And that's going to be in ounces per minute, because we are looking for the rate.
This is for all you sophisticated ladies out there. She grew up in the city in a little subdivision.